Today we go behind the scenes with Dretuned.
While I was waiting, I was just messing around with a lot of stuff, a lot of protection with the computer, and I lowered the boost cut. I have to remove the boost cut now, and then be able to do a clean pass.
We first met Dre last year as he was drag racing his 1300 horsepower all-wheel drive Mitsubishi Colt, which he built and tuned. And we wanted to know a little bit more about what goes on behind the scenes in the world of being a car tuner.
We're here with Dretuned. Yeah. We're trying to pick his brain into his style of tuning, his experiences, and see what's going on. So, Mr. Andre Wade.
Hey, what's up, man? How things doing?
Taking your time.
Alright, no problem.
Alright, so first question that comes to mind is, why did you start tuning?
Why I started tuning? Engineering is my thing.
Okay.
I always love from primary school picking at little remote control cars, mechanisms, components. Used to pick apart, like someone would give me a remote control car as a toy, as a gift.
Yeah.
And that wasn't just enough. I would pick it down, dissect the motor, and then try to make things of my own, little devices. So like making things was just me.
Yeah.
And then when I got into understand electronics, the engineering, electronics, computer programming, then I started messing around cars and stuff growing up. It was just one thing after the next, and it led to the tuning because I love making anything better for anyone.
Okay.
Seeing things develop in front of my face. Knowing that I helped make this what it is today, seeing by adjusting a couple numbers, a few parameters inside the computer, getting the car to run as smooth as possible, as efficient as possible, as powerful as possible. Yeah, so that's just me. It just one thing led to the next, and now I'm here.
Okay. So, and next thought I had is, how would you describe what tuning is?
First and first, let's say everybody has a misconception of what tuning is.
Yeah.
Right? People think that tuning is just changing spark plugs and oil in the vehicle to make it run, maintain the vehicle, making it run the best way possible.
Yeah.
That is one aspect of tuning, yes. But when we consider tuning here in the Caribbean and the world is more computer programming, getting all the features, functions, parts, all the components in your vehicle work together to make it run right. So tuning is bringing everything that comes together and making sure that the coding, all the strategies and different things work well as they should to make the engine and the car work right for whatever purpose, whether it be for rallying, whether it be for dry racing, drifting, whatever it may be.
Yeah.
So tuning is everything that is involved in doing that.
Okay. And in your mind, you have like a roadmap, like how you select a tune, like what you tackle first, like steps of.
So let me start from the basics.
Yeah, give me an example.
Start from the basics. Like, okay, there are many different computers and platforms out there that you can make, that people have as their own, and you can alter and adjust for yourself to change whatever you want. So like in the automotive, in the motorsport world, like say dry racing, circuit racing, rallying, all right, there are a lot of automotive computers, programmable computers out there that are available that guys use.
Yeah.
So there are brands from ECU Master, there are brands from AEM, there are brands from Haltech, there are brands from Wolf, there are brands from Link, there are brands from Cyvex.
Yeah.
There are brands from, what other brands are there? There's so many. I tend to forget some of them.
So the fuel tech, the Haltech,
correct. So there's so many brands that you work with. Like to start from the basics, one, you have to spec the computer for the platform or what application you're looking to use it for, right? So you have to know the engine you're using. You have to know what car is going in and what's the purpose for it, how many inputs and outputs you're going to need. If it's a daily driven car, that's going to need like a lot of closed loop tuning and adjustment. If you're going to be running, if it's a full dry race car, if you have a lot of controls by the computer, whether it be electronic boost control, CO2 boost control, fan control, fuel pump control, multiple pumps, lights, different things. You have to know what where you're gonna apply it to,
Yeah.
to then decide what computer you're gonna choose.
All right, so we go with
And that's the first step. As you asked me what the
yeah,
steps
this
are.
first step.
Yeah.
I didn't even think, I thought more so from after you got the computer, but you took it a step even before
Yeah,
that.
so it's not as simple as some may think it is.
Yeah.
So someone might come to me and ask me, okay, well, Andre, I need to get this car fast. I need to make it work right with all the changes that I
Yeah.
did to the engine. Yes, you need a programmable computer.
Right.
Okay, what is your end goal? That's the first thing I ask anyone. Even when I'm working on the trucks, like this one I'm mapping now.
Yeah.
Like any of the cars, what is your end goal? You know that you're in the future you're gonna change turbo, you're gonna change injectors, you're gonna change this or whichever, and possibly you can do some track racing, some drifting, whatever it may be.
Yeah.
Right? So okay, you need a computer to adapt to everything that you do moving forward. So you need something that is new, because
Yeah.
technology changes constantly over time, and you need something that can be updated and get support from the manufacturer. You need something that has a fast processor. So you need a computer that can match your needs whenever you do to make changes in the future.
Okay. So, all right. So let's say now, actually you can show me your laptop. Let's say now you have your computer.
Yeah.
You want to start the process. What is in your mental map? The things you want to tackle, what's the order of operations, and you get this car up and running.
Getting car up and running is getting the best components possible, because you don't want to cut corners or create any shortcuts when it is that you are building a car or tuning a car or getting ready to tune a car, right? So you want to make sure you have the best quality sensors,
Yeah.
the best quality wire harness, the best quality injectors, coils, all the components that go hand in hand. Because again, if you don't have the best or the best for you at that point,
Yeah.
it's not going to work the best.
Okay.
Then you're going to run yourself in problems. Like, okay, you spend $3,000 to $5,000 in a computer, right? But then you want to put on Chinese sensors, right? So when you hook up everything now, you realize you're getting interference from the sensors and they don't work properly. When you're tuning the car, you're getting misfires, you're getting inconsistent readings when it comes to temperatures, pressures, and different things. So you don't want to spend money twice, and you don't want to frustrate yourself. And as a tuner, yes, everybody doesn't have the same budget, but
Right.
I tell them straight, if it is that you want to cut corners,
Yeah.
and you want me to work on it, it's going to be a problem, because I'm going to do a job now. And if you have components that are not the best or are most suitable for you or can do the job, actually, what's going to happen is I do my work, and then you leave from here, everything was working good. You go home, drive the car for a week or two, you put on the car, next thing you know, something changes, like battery voltage or the alternator charging rate or something like that, and the car doesn't work the way as when you left from by me. When you check, it's a sensor that is failing. So the calibration that was there for that sensor from the time of the last tune it to now is went off.
Yeah.
So the throttle position doesn't work the same way. Map sensor doesn't give you the same reading. So then it throws off the map. And the first thing that people do, the tuner. Tuner this, am I wrong? I mean, he goes down and he talks to his friends and stuff about, man, this car is not driving as good as it used to. Something happened, whichever. The first thing, it's come to be a cultural thing.
Yeah.
The first thing that guys do is blame the tuner, right? If the engine not, they blame the tuner. Man, you ain't had no oil, right? If the car has a misfire, right?
Yeah.
And he had plugs in for the last 8 months and just starting the car when it's cold, shutting it off, and it had went through some rich cycles or different points, and he followed the plugs, man is misfiring. What he does, blame the tuner, right? If he lost a race, blame the tuner, right? If the car won't start, blame the tuner. Man, the battery's dead, right? Different things. So anything that happens, watch it. Anything that happens, the first thing people like to do, blame the tuner, right? Simple as that. But it is what it is.
It's all real burn.
But like okay, all the tuners in Barbados,
Yeah.
everyone knows one another, and 90% of us, we are all friends. We
Yeah.
work together, we communicate with each other. Like my good friend David Balgo in Bali, like he got me into it basically, starting from SDS and other older systems that don't even exist no might protect different things, and he taught me some stuff. Then a lot of stuff I learned on my own. Did some classes online or overseas.
Yeah.
So and then over the years with personal experience with the different components and cars and ECUs, I gained my knowledge. This is like 20 something years I'm in it now. And what happened is now that, like, okay, again, I was saying, I lost my mind there just now. the guys that work together, like
Yeah.
say David Bagwell, Bali, Fabian, Fur, we have Dennis Heath, he's a good friend of mine, Dennis. Have to give him a shout later on as well. We have other guys. There are so many guys that I can't recall the names.
Right.
Into tuning, even in overseas, a couple of guys that into tuning. So it's like a lot of people are into it.
Yeah.
A lot of people know what they're doing.
Yeah.
A lot of people don't really know what they're doing. But Barry Gilles is a good guy. He's into tuning as well. I learned a lot from him.
Yeah.
So again, like people will have their preference on who they want to go to tune their cars.
Right.
That's okay. But again, and then they will go to one tuner, then go to the next, and then want to bash that other tuner. But there's a lot of things that happen here in Barbados and I guess around the Caribbean that makes the whole industry a messy place at times.
Yeah.
Right. So that's why as the more mature you get in this industry, you'll find people making sensible decisions to suit them. Like, okay, I don't tune in every car that someone brings to me, right? Because I've had some experiences in the past that have really turned my mind from actually doing it.
Yeah.
Like a guy, for example, will come here, Dre, I want you to make her, and he'll come here the roughest attitude, whichever, and I'll be like, okay, cool. I don't want to deal with those guys. Cool, no problem. Because give me a time, we schedule a date and time, we come and do it, whichever. I give him a chat list.
Yeah.
And even though I give him a chat list, he's gonna come. We're gonna go on the road, tune the car, or go on the dyno, whichever. And the first 10 to 15 minutes, run yourself in problems. So what's happening now? The car has a misfire. Well, did you put in a new set of plugs? Man, these plugs good, man. These plugs are here for a month. I said, for a month, under what conditions?
Yeah.
Right? It doesn't take much to fold up spark plugs. When last you got the injectors clean? Are these brand new injectors? Different things like that. So customers come expecting the most, but doing the least, right? So they know the results now. The first thing, remember we told you before, the first thing to do, blame the tuner.
Yeah.
So if you go on the road now and I say, okay, tuning doesn't take long. Once all the mechanical and electronic components are working the way they're supposed to,
Yeah.
right? Are installed correctly and functioning correctly, tuning takes 30 minutes to an hour. All depends on what you're doing with tuning. You're tuning like getting your load point set, your part throttle, transit throttle, and different things.
Yeah.
It doesn't take long. Once you know what you're doing, it doesn't take long. Like you could go in the dyno, and a dyno session could take you from half an hour to an hour.
Right.
If you want to tune different load points, the most it could be is 1.5 to 2 hours max. And 90% of the cars that go in the dyno that gives issues or on there for a long period of time, they have mechanical problems or electronic problems that the tuners are trying to iron out or fix at that
Yeah.
point in time. That because it tend to rack up. But other than that, tuning doesn't take long. Simple as that. Like, okay, when I go in the dyno, I make sure I have another checklist for myself personally. I check everything: plugs, injectors, fuel system, pressures, everything is running right the way it's supposed to. Engine health. So when I go in dyno, I know what I'm going to do, and everything. Most things are working. Yes, you may have problems that you don't foresee,
Right.
but at the same time, it doesn't take long, right? So then now, go back to the same thing we're talking about with the guys coming here now and wanting to get a car tuned. They'll come, you get them a list of things to check. They don't do these things, want to half-ass it, right? And then run yourself in problems. We go on the road for it's supposed to be half an hour to an hour.
Yeah.
Next thing you know, you run yourself for 2 to 3 hours because he has mechanical problems, electronic problems. He has a wastegate that's sticking. He has injectors that are failing, spark plugs that are failing. So then now, it looks like you don't know what you're doing, but in truth and fact, he doesn't have the components to make everything work right. And the first thing they do, man, he was on the road with me for 1.5 to 2 hours, man. It still ain't working. What happens? The tuner is the tuner fault. He doesn't know what he's doing. Nope. Most of the time, ask any other guys. It's always that the guys don't follow that checklist and make sure everything is right.
Yeah.
I want to bring you half-ass stuff, and then it doesn't work.
So let's say the mechanical and the electronic stuff is sound. Now we get into the part that you would have done years of courses and research
Yeah.
on. That part, no, you finally get to that part.
Yeah.
What is the most fun bit of it for you? Like, what segment of that?
The most fun part of me is getting everything to work, right? It's like you building a house. It's
Yeah.
like you building a boat. It's like you building a car from scratch, a logo car, anything. It's like you doing a project at work and seeing it develop to the final stages that is successful is knowing, okay, you coming from setup from start to finish, and you getting the car to start up for the first time with this computer, getting it to run, getting it to drive smoothly for the customers' lickings, then building the power on it. Then know when you're in the dyno, you getting to see everything you do, every change you make, see how much more power you make, how clean the graph is, how reliable the car is. All those things bring a feeling to you that is just unmatched. It's just amazing. You just love it.
Okay. I could get that.
Yeah.
I get that because personally it felt similar.
Yeah.
Where you finally figure out how to connect all the dots together.
Correct. Because everything has to work together for it to work overall. Because like, okay, let me show you. You have some cars that are easier than some to build and tune. Okay. You have cars that are natural aspirated. Yeah. All right. You have cars that are natural aspirated with one type of camshaft. You have cars that are natural aspirated that have variable valve. You have cars that are aspirated that have variable valve and lift. So then, like, say the more advanced engines are like the K series engines and the new Honda engines that you have variable valve and lift. So you can have variable, different variable parameters that change at any given time. Yeah. You change it how you want for your driving style, for your power output. If you want the car to be torquey at the low end range, and you want it to be torquey upstairs, you want it to be to pull harder above a certain RPM. You don't want it to be as powerful below a certain speed. So you want to reduce the power below that wheel speed for traction purposes. So there are a lot of things that you have to adjust and do to get the car work how you want it to do, how you want it to work. And as a tuner, you have to take the input from the owner or the driver or the racer, whoever it is, to then make your adjustments to suit them. Okay.
And what has been the hardest thing for you to figure out tuning wise? Because not necessarily a problem, but a concept that you had to get your head around.
The hardest thing for me was understanding that not every engine is the same. Okay. Right? Not every computer is the same. So how you would approach tuning a car that is, let me get myself straight here. How you would approach tuning an engine that is a cast iron block to aluminum block, or tuning an engine that has, all depends on the porting of the head or the cam profiles, two different main engines. Because, like, say for example, let me make it simple to you. Honda engines and Mitsubishi engines, they have to run the same way. Air, fuel, you build power, cool, no problem. But then no, there's so many things because of how the engine is built, right? The engine operates differently. So you cannot run a Mitsubishi engine as lean as you would run a Honda engine, right? In terms of building power. And then you have to know your cam profiles, your compression ratio, your cam timing and different things. You have to know how everything works together to achieve what you want. So it's not just the computer as well. You have to know the engine specifics exactly. So then it's understanding how each engine works together was the hardest part or most developmental part in my career coming up when I was younger. Because I used to think, okay, well, air and fuel and some ignition timing, you're building a lot of power. No, And then also too, a lot of guys now want these pops and binds and these burble tunes. Don't even call me, ask me for this, because they tell you no. Because I tell you, the guys want to hear that these swifts and stuff, pop, 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 like keep it very noise. Nope. Every pop you hear is stress on the engine that the engine was built for, and they reduce the lift of the engine. So don't call me. But the first thing is going to happen when it dies with you, the first thing you're going to do, manage the tuner fault. No, I have learned my lesson over the years. Yes, we have experimented with more of my personal vehicles as well. Customers that want me to experiment with different cars to get them like go fast and try different things. But then you see the results, and over years, you know what happens when you press the up button too much, right? So like, you know what? Okay, let me come by. Correct. Okay. So then also the different monitors that we use to make things safe and easier for us when we tune. Like they're not monitors, air fuel ratio gauges that and monitoring different parameters within the ECU. So you always make sure the engine is safe. EGT sensor, a lot of different things, sensors are used to make sure everything is safe when you're tuning and after you finish tuning the vehicle. Okay. And another question that popped in my head is I'm trying to think how to phrase it. I can give you an example. You tell me. For the example, I'll try to phrase the question. So the different methods of measuring air. Right. So you have the mass airflow. Mass airflow sensor.
and you have speed density, volumetric efficiency.
Yeah.
And most recently, I have heard of not from the so for speed density, you use the pressure sensor
Yeah.
and air temp. Other
Correct.
methods you can use coolant temp if you really want to do
Correct. To
more.
put compensations on different things.
Yeah. Instead of okay, let's study the reason why is MAF a thing in the first place? Why do OEM manufacturers have that exist in the first place? So then that had to come around because
Yeah.
of the precision of MAF.
Exactly.
Right.
OEM manufacturers, more of the cars will go with mass airflow meter
Yeah.
for, as you said, the precision of the tune on the vehicle.
Yeah.
And you providing a OEM vehicle for a customer to drive around that wants no issues, no problems. You have to put the computer has to be able to adjust continuously while the person is driving it to make it more user friendly for them. So it continuously changes the map and alters different things to make it more make it the most fuel efficient, make it the most reliable,
Yeah.
and still give you a decent amount of power to operate the way it was when they stated it in the brochure when you bought it. Right? So you would get the mass airflow meter. It always measures the volume of air going into the engine, right? At any given time, right? Along with other sensors now to make the adjustments that the computer has to make sure the engine runs the way it's supposed to, right?
Right.
Compared to the pressure sensor now, that measures the pressure at the intake manifold. So you could have pressure and volume of air, two different things, right? So you could have engine running, say at 10 psi at 3000 RPM, right? And then on the different conditions, at that same 10 psi at 3000 RPM, you have a different volume of air, right? So it's not being, with the map sensor, you're not able to measure the volume of air properly for those change in different parameters. So that's where the airflow meter now, for especially everyday driven cars, is better able to measure the volume of air going into the engine, because the volume of air going into the engine at any point in time is the volume of air going into the engine at any point in time. So what's measured here for the volume of air is what the engine is getting, right? So that's why you okay about this particular volume of air. Let's make it as simple as possible for you or for everyone that is to watch. When you measure the volume of air, you know you have to inject this amount of fuel. And at this particular throttle position, this particular road speed, you calculate the load, and that is how you get the most fuel efficient burn.
Right. So we have that in math, and speed density is the combination of the intake to air temp with the pressure, and that's so you can calculate the same amount of air.
Correct. Yeah.
The third method would be air velocity. Whereby you have, what the pressure on one side of the throttle body, and pressure on the other side, and that pressure differential then you can calculate the volume of air.
That's another way to do it as well.
That's an example of, as time progresses, you have different methodologies of calculating that. Do you have any other systems that, as time progressed, gave you a fascinating methodology? Because that third methodology, you don't see it in 90% of cars.
Yeah, you don't see it many cars because that particular one you mentioned last, there are too many in my mind, everybody may have a different thought or view on it. There are too many calculations to be carried out at one point in time to just inject fuel into the engine or carry out a particular action. Right? So then now you have a lot of components that may fail and may cause the vehicle not to work correctly. So again, that may not be the most feasible or reliable option to use for the application that is going on. Right? So that's where you see a lot of manufacturers not going that route. Right? Again, manufacturing, relating it back to business, how you make money. You operate at the least cost, providing the best product for anyone. Right? So you as a car manufacturer, why are you going to expense yourself in a system that you need 4 or 5 components to get the engine to run, when you could have, and then it's not the most reliable, but then you could have a system that uses 2 components, 2 or 3 less components than the other method, and it is more reliable. So you reduce your cost and you have a more reliable product for your customer. Which one will you choose? The one that is least amount cost. The one is least amount cost and the most reliable for achieving the goal that you want.
So it's math.
Correct.
So math is good enough, even though pressure differential methodology is the benefits of math and the benefits of map, speed density, but the con is the increasing amount of cost. So then I go back to your answer. Apart from that system, right, other methodologies that seem to be interesting to you?
Yeah. Some guys you find more in the race applications for aspirated vehicles with like throttle bodies and stuff. They just use throttle position by RPM because the cars don't really drive. You find it difficult to tune the cars at low RPMs and stuff, but you guys are wide open throttle 90% of the time. So that methodology works for those applications, simplifying things for racing.
Okay.
You have less components to fail.
Right.
Because for racing, like say, okay, you in a rally or in a circuit race, and one of your sensors fails. Like, yeah, that's a problem, right?
Yeah.
So don't you having the least amount of components there, you have easy to fix, and then you're not reliant on it. So that works for that application. But driving like normal everyday driving, I won't recommend it.
Okay.
That's one way. Then you also too, you will find that even like say for fuel injection to the engine,
Right.
you've seen some setups where the injectors are outside the intake manifold, like in front of the throttle body, right? To provide a more atomized mist into the engine for different reasons, aspirated applications, right? So everybody, all different manufacturers, tuners, developers, whoever they may be, have their different views or methodologies that they think work for them, and some of them have them proven, some of them have not. So you'll see so many different setups out there. Again, that's what you see now. A lot of cars, rather than coming from the normal common fuel injection setup, are running direct injection. So you see, like this car here, for example, this engine comes onto the new FK8 Honda Civic, the turbocharged K series, and it has direct injection, right? Compared to the previous K20 models that have the normal. Either high impedance or low impedance injectors, whatever it is, right? Saturated injectors. So again, as technology advances, right, finding ways to harness the burn, how the engine, the power of the vehicle and how the engine operates, right, is key. So you find engineers spend their entire lives in a little air conditioning room developing this just to make sure they get the most out of the engine at the least amount of cost and being the most reliable. Right. So in a couple of years time, well, they're going to electric now, but in a couple of years time, you see some other component come up to be as more advanced than direct injection. So it changes over years and over time.
Direct injection, that's for efficiency, but is it for power as well? You find?
Yes, because direct injection allows the fuel delivery to be more, the fuel deliveries to be more atomized, allows you to build more power, and allows you to, as it says, speaks for itself, it allows you to direct the fuel where you want it to be within the cylinder, right? Compared to a conventional injector that is injected in the intake manifold, then it has to flow down the intake ports, then into the cylinder. With direct injection now, it fires straight inside the cylinder. So the combustion is way different, and it provides a different result.
Okay, cool. Liam, we boring you too much?
No, I'm just handling some stuff.
Oh, okay. Yeah. So, as I said again, tuning is a lot that goes into tuning. Is not just hooking up a laptop to a computer.
Right.
It's not just like bullshitting your way around things, right? You gotta know what you're doing. It doesn't come like straight off the bat. You wake up, you're born with the talent to do it. No, you have to sit down and learn. You have to go to school. You have to understand how components work and understand how everything works from the body design from body design, aerodynamics to the engine components, what they build to achieve what you want, the suspension, the brakes, different things. All that is dealt into tuning because everything works hand in hand, especially in the more precise and particular applications, right? Where you have, I was watching a build online for a truck that simulated a Land Rover, right? When I finished, I was sending the link for it. It's amazing. The engineering behind this was just phenomenal. And this truck had 4-wheel steering. This truck had 1,500 horsepower. This truck had suspension like a Formula 1 car and different things. It's just everything that went into it to let it operate the way it does was just amazing. All of it is controlled by a computer. And to do that, everything has to be tuned.
Yeah.
It has to be programmed and tuned. And watching that documentary on that vehicle, honestly, I fell in love. That was
The Range Rover Velar that they built into the off-road monster.
yes,
The fenders move with the suspension.
correct. That was just trust me. I have never seen any. Yeah, yeah,
It's like the silver Range Rover Velar. That they
right.
have massive wheels on,
Correct.
whole new suspension.
And that's the only car I ever saw that the fenders move. The suspension comes up to a certain point.
Yeah.
And when it gets to that point, the fenders move with it. Because obviously the suspension travel the vehicle has, the wheels will have to be out so far
Right.
that they have to be separated from the fender.
Yeah.
But to get that to everything to work, they'll come out like say like 6 inches,
Yeah.
and then it hits a stop, and then the fenders will move with the suspension travel, and that alone blew my mind. The four-wheel steering and everything, yeah, that was great.
Okay.
Yeah, even like the cars, for example, oh sorry, let me talk about this. Tuning and where we have come from over the years has advanced drastically in Barbados.
Okay.
Right? I remember before the guys used to tune and never had a wideband controller to monitor these things. Right? So it used to be hard. We used to guess. And yeah, we used to like a lot of stuff used to be damaged and different things.
Yeah.
But then no, things got more advanced. Everybody knows what they're doing. So it's pretty good. A lot of guys are able to achieve higher horsepower figures a lot easier and quicker than before.
Okay.
Right? Like my race car, for example. When it first started coming up from like say 700 horsepower. Now
Yeah.
I'm up to 1100 horsepower at the wheels, 1300 at the crank, and like years before, this is not achievable in Barbados, right? We have guys like Jimmy. He has a Skyline there. He got 1,000 or some. I can't remember the exact figure he got, which have a half body. He has a Civic there, and he's at 1,000 some horsepower as well. So most of his cars are in that 900 to 1,000 horsepower range, and like say 10 years ago,
Yeah.
that wasn't attainable so easily, right? No, everything comes like everybody knows the combination. This works with this works with that. This is what you have to do. Boom, it works. Then again, it does another thing.
Yeah. So, okay, you prefer to perfect the fine tuning of road tuning, or you prefer to try to ink up that little bit of horsepower? Which style you prefer?
Well, this is my style. Any car that I am dealing with, I always go on the road to tune the car first
Yeah.
to minimize the cost for the owner.
Right.
Because when you go on the dyno, if you won't know setup, I do not ever recommend anyone to first go on the dyno as soon as you set up the car, because you have a lot of things to iron out.
Yeah.
So I always set up the car inside the garage to make sure everything is right, set my timing, make sure the injector dwell times are correct, make sure all the sensors are reading right, everything's functioning right, make sure the mechanicals are working right.
Yeah.
Then I go on the road and do some road driving with it to get the car working the way it's supposed to, or get it 80% there.
Right.
Then I go on the dyno to then fine tune it now to see where the power is at and where you want it to go.
Okay.
Like say some guys, instead of having all the power at the mid-range torque, it just wheel spins a lot.
Right.
So they want the power upstairs now, so that when they accelerate, they maximize the use of the vehicle and still have fun with it. So I prefer to go on the road first,
Yeah.
then go on the dyno to do what you need to do.
Okay.
So like, then let me talk about the difference in the trucks, right?
Mm-hmm.
So automotive vehicles, gasoline burning vehicles,
Yeah.
you inject fuel for the more air you put into the engine.
Right.
The more air you put in the engine, the more fuel you're gonna demand, the more power you're gonna get.
Yeah.
Right? Diesel vehicles now is a little bit different, right?
Okay.
The more fuel you put in the engine, yeah, the more air that comes there, and the more power you make. Right? Through the like commercial diesel engines, the injectors fire directly into the cylinder, like direct port injection for the gasoline vehicles.
Right.
But the methodology for combustion and to burn and build power with a diesel engine is different.
Okay.
So you have to, a lot of the strategies you would use for a gasoline engine is different to a diesel,
Yeah.
right? Where for gasoline engines, we monitor air-fuel ratio as the first thing to monitor to see how the engine is working.
Yeah.
Diesel engines, yes, we monitor air-fuel ratio, but we're more concerned with exhaust temperature, right? You monitor exhaust temperature in gasoline but exhaust temperature in diesel vehicles is extremely important because cylinder temperatures can become extremely high, extremely easy in diesel vehicles, and that reduces the life of the diesel engine.
Right.
Right. So diesel tuning is something that is escalating now in the Caribbean and Barbados. It's not the same. Like you see guys these ZR vans out there driving black smoking over the place. The older vehicles that have direct injection that you don't have much control over it. No, everything is more advanced.
Yeah.
You see, I have this laptop here,
Yeah.
doing some stuff on this truck, and it's basically, yeah, you have control over everything from a computer, right?
Okay.
So that is it.
Well, thank you.
No problem. Anything else? Aerodynamics.
Yeah. 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 How do you approach aerodynamics of the tune?
Again, it goes back to the particular application,
Yeah.
right? Wait, hold on. When you say aerodynamics, you mean aerodynamics on the car?
Yeah.
Yeah. Each application is different. So you have a car for circuit racing.
Yeah.
You have to understand how aerodynamics comes into play for cornering and put on the best lap times.
Right.
But at the same time, aerodynamics holds the car to ground, but is a hindrance in terms of straight line speed.
Okay.
So you have to know, okay, how much torque you want to apply. You want to be able to apply to the vehicle when it is required, and you want to know how the engine is supposed to run at that particular time. So you have to know, okay, well, at this particular gear with this amount of G forces, which is a relation to the aerodynamics on the vehicle, or the force is being put down by the aerodynamics.
Yeah.
How much more torque should you be able to implement at that point in time?
Okay.
Or how much more power you're supposed to implement to get more speed through this particular point, right?
Okay.
Then, like, so okay, for tuning, let me give a good example, make it as simple as possible. I had a couple years back, I had a car that I was tuning, and I realized that 1 week it was one way. The next week when he came, he realized that he told me he wasn't getting past like 140, 160 properly with the vehicle. It feels like it was straining.
Yeah.
Right? And it baffled me for a bit. And when I realized, okay, well, the tune isn't that nothing much is off, but I realized that it is straining at a particular point in time. But I can't figure out why. When I checked, it was because he installed a wing on the vehicle.
Right.
And the downforces from the wing was the fast he got was giving more downforce on the vehicle and more resistance to the vehicle.
Yeah.
So then that is why it felt as though the car was pulling back on power.
Right.
We took off the wing and the car went back to how it was or even better,
Yeah.
right? So it was pulling past like 200 kilometers easily. And then we said, okay, well, this much from a wing. Yeah, so when it comes to aerodynamics, again, the application, you have to know your application and what you're going to use it for. And don't just go and put a wing on any wing on a vehicle or canards on a vehicle. Yes,
Yeah.
it looks racy, it looks good, but everything is for a purpose,
Yeah.
right? So you have to know when you put on these things, you are actually slowing down the vehicle because you are pulling the vehicle to the ground.
Yeah.
At the faster you go, so the vehicle may not feel as fast as you would like it to go, and you don't realize why.
Yeah.
So when it comes to tuning now, if you don't have tunable aerodynamics that are controlled from a computer, like adjustable wings or canards that adjust the downforce on the vehicle at any point in time, you have to know at what particular speed you have to apply more torque here or less torque here to give you the maximum traction in whichever application it is.
Okay. That answers what you were thinking about?
Yeah. One last question. What's your favorite engine?
Yeah, what's your favorite engine?
I don't have a favorite engine. Actually, I like both versions of the K series. They're a lot more friendly to adjustments for various applications compared to the B series. I do love tuning the Evo engine, but that has been sold for years and nothing has changed with that. It's basically the same for the last couple of years, but I love the advancements of the K series engine, the Honda engine, and how that is working. So when it comes to tuning, I think that is something that I have a more greater passion to or a greater love to, right? Because one of these days, when I get a chance and I have another vehicle here, a K series engine, I will call you across and let's run through it and let me show you how many different parameters within the Mac or the computer you have to adjust to get what you want. and seeing that you have so much control is just magnificent. Yeah.
Okay.
So one thing I don't really like tuning that much is
4AGs.
no, 4Gs are simple. 4Gs are simple. Subarus. Subarus are lovely because I love a Subaru, but they're extremely delicate at some points. I had a friend of mine, I think 4AG who even told me this, and we just laugh at it all the time. You could cough too hard, and a Subaru engine probably not. Yeah. If you scare a Subaru easily, yeah, something's gonna happen. But the guys right now, even myself included, are getting more Subarus now. You find a lot more Subarus racing.
Yeah.
Because as we get with experience gained, you know what they can take and what they can't take.
Right.
And you know the limits of them way before it gets to that limit.
Right.
So the guys are getting more fun out of them now and racing them more.
Okay. So I shouldn't be too worried.
Yeah. And then it goes, you shouldn't be too worried. Anything you need help with, just give me a shout. I'm ready to help you. Next into even tuning, like even the bikes, the 2-stroke engines, the 4-stroke engines. Yeah, when it comes to tuning, you gotta know exactly how each engine works and operates. You gotta know the mechanical side of it first, before you go and tune it. So if you have a tuner, if you're going to get somebody to tune your car, right, and they have little to no mechanical knowledge of these different engines, you run yourself in problems, right? Because you need to know how the components work before you get involved with it. Because tuning a bike is different to tuning. There's some basic things that are the same. The general things are the same, but extracting most of more power and making sure it's reliable as possible.
Okay.
Yeah, you have to know how that engine works before you sit down and start tuning it. Because you can mash the things, it can get ugly really quick.
Yeah. And a bike, if you driving a bike and a bike just say, we're gonna stand a piston out the whole.
Yeah, because bikes are high compression, they're more lean burning. And you just go, there's some of them are simplified, but they got more advanced bikes now, like the BMWs and the Kawasaki's and stuff, turbocharged bikes. So you just have to know exactly how they know the components, how they work, how they work together, and go from there. And then know the jet skis and boats, that's a whole nother thing now. Right? I did a couple of jet skis before, and they're basically a bike engine. But at the same time, it's always on water, it's water cooled, so it operates a little differently. Okay. Right? So you just have to know the concept and how they're set up and the specifics of them before you get involved with tuning them and to get the most out of them. Okay. No, not playing yet. Not playing yet. Yeah. That's something like I would honestly like the experience to sit down with some engineers that have developed the engines for planes, for cars, for bikes, boats, trucks, whichever, and see what goes into making it and why they made it this way. You know, we always say like, why these small men made this boat to fit this place or that, or why they choose to set up this way. I like to sit down with the engineers for different manufacturers to see why you did this to achieve what. That's one passion, one interest of mine. All depends what you want to use it for. If you want it for drifting, you want initial torque low down. So you want something, you don't want something, if it's turbocharged, you don't want it spooling too late. You want torque, you want something with CCs that you don't have to rev it too high, that you get torque every time you mash it, mash your throttle. Drag racing, you have to know, okay, drag racing is a little simpler. You know you have to get down that quarter mile straight by a certain time, you want to do it as fastest way possible. So you have to know, okay, what gearing you have to know your tire size, you have to know your gearing inside the gearbox or the differential, you have to know your engine RPM capabilities, and then know your engine RPM capabilities. You have an engine, a high revving engine, you know exactly, okay, well, you have a high revving engine, so you're able to have a lower gearing, then now, so you don't have to, so everything goes hand in hand. You have a high revving engine, you can have lower gear, shorter gearing because you're going to make up for the speed because of the RPM. And then now you are able to run a bigger or smaller tire. Then now if you have a lower revving engine, you know you have to have even lower gearing now because the engine can't rev that high, so you have to get you have to maximize each rotation of your wheel to get down that straightaway as fast as possible, right? Because you don't want to have a car revving to 7,000 RPM and then your tire rotation you on like 13-inch tires or 15-inch tires, and you're limited to how much speed you get per rotation on your wheel, right? So you have to know what works for your application and go through there. So when it comes to tuning, I honestly prefer having a higher revving engine, having my power upstairs so I don't have to worry about traction loss down bottom. There's a little less torque in lower ranges, but again, everybody, it's each your own. Everybody has their different preferences. So again, you get somebody desiring something different from me, right? But that's just me.
Okay.
Anything else? Well, 10 flies. Yeah,
Thanks,
10
man.
flies. All right, cool, boy. Anything?